Hello guys, this new topic dedicated to vectors as directed segments. Basically, it's not a scalar, it's a vector quantity, so amongst magnitude it should have a direction. So if you're ready to that, let's get started. So first we give presentation of what vector is. So vector is simply directed line segment. Okay, so this is the way how we can present a vector. If we take the line, any line that goes somehow, we can actually use 2 points. That actually means the segment AB. And we have an arrow that shows actually direction of your vector. So let's have a look. In this case, AB, we can set up the arrow above, overhead. That means we have a vector. So this is a vector. As you can see here, it's just simply directed segment. If you have a look here from A to B, it goes along the line. So because the line has the gradient, obviously it has some direction, all right? So because the line has the gradient, so gradient can define the vector. So that's why that makes sense that we're talking about direction of the vector. So by the way, this is the segment, right? So what it should have the length. So that's why this is the length. Okay, so that's why vector AB should have the magnitude or a length. So magnitude, basically the length, and it should also have a direction. So direction to what? So of course direction is a relative measure. So if you have, let's say, a horizontal line, so you can figure out the gradient, right? So that's why your gradient, as you remember from trigonometry, it's connected with the tangent of alpha. So basically it's connected with the angle. So let's say with the theta in degrees. So hence we can define direction of the vector. Okay, so later on you actually come back to trigonometry when I explain vectors in full, and here is going to be the link to trigonometry so that you connect the ideas and theoretical basis you've got from trigonometry and apply it to the vectors. That's very significant. Here we just stop at the magnitude and direction. Okay, so how we define the magnitude? So we just put the absolute value, like modulus, from the vector, so of the vector. So about direction, we need to know the angle relative to some x or y axis. So that's why in order to define vectors, first of all, you need to put Cartesian plane or xy set in order to define direction, so relative to some axis. So actually this also can be possible to input the bearings, true bearings, and that's why I use the direction from the north direction, as you remember. So that's bearings from north direction. You can set up your vector, let's say that one, which will have some angle theta from the north direction. Okay, so that's actually shortly about vectors as directed segments. And let's actually define which values. Now let's see some application and try to define which values, physical quantities, are actually scalars and vectors, and what's the difference. So scalars should have only the magnitude. They don't have any direction. For example, let's go back to the physics. So for example, temperature, that measured in Celsius or in Kelvins, doesn't matter. So it doesn't have any direction, right? You just measure temperature. And if you apply some, thermal physics equations, that will be about just connection with other quantities. They are scalars. So temperature is scalar. So pressure is also a scalar. So units for pressure, pascals. So we can also input, let's say, time. Of course, you can say that time has direction, right? And actually, you can put it along on the axis, But if you're just consider any equation, let's say from physics, let's say any equation that connects time, distance, so you can see that displacement s, which stays for s, so displacement, if you have 2 points, and no matter how body is moving, that's the starting point, start, and this is the end. So you understand that displacement is just the vector connecting the starting point and ending, so towards the end point, okay? So that's why in this case, we can define displacement as velocity, also a vector times time. So time is not a vector at all. Yes, it has a direction of in which direction the time goes, right? It flows obviously in sort of increasing values, but it's not the vector, okay? So next one, quantities which have both magnitudes and direction are called vectors, all right? So we actually define this. And let's see some examples. So first, a pretty obvious example is the velocity, not the speed, not actually what driver can see on the panel of the car when he sits on the speedometer. So he sits and just actually observe the speed. So speed versus velocity, so speed versus velocity is the scalar. However, velocity, it has a direction, okay? So for example, a body moving to the east or in the east is direction. So that means we can define direction of movement, right? That's velocity. So displacement, as we define it from starting point to ending point, okay? So displacement, let's put S. So displacement, yes, but what about the distance? Distance is definitely scalar, okay? So distance is here. That stays for a scalar. Actually, that's really a lot of vector quantities. If you go to Newton's mechanics, so force is actually vector. Acceleration is also vector. So, for example, what else? Angular acceleration. So omega. That's more, higher level stuff. But anyway, so you understand that basic application, if you can define the direction, it's going to be vector. Hence, you also can define magnitude. Okay, so for example, velocity. Let's set up velocity vector here. Okay, that's velocity. Okay, the length of the arrow represents the size of magnitude. But how to measure the length? Of course, you can take the ruler, and for example here, because it's drawn somewhere on paper, I can zoom in, I can zoom out. So it means every time you apply the ruler, right, it will have different lengths. So how to define it properly? You need to use the scale. You need to use the scale. What sort of scale? The scale that actually convert your points or your, let's say, units on paper into real units, like centimeters in reality. So for example, in our case, let's say that we have this, and right now it seems to me as the centimeter. So 1 centimeter. Of course, we can apply the ruler, but how to figure out if we don't have any ruler? So we can measure, right? We can measure. But how to figure out if it's like plot on the grid line, like here, how to define the vector? So it's pretty easy. Look here. So that's what sort of triangle? Right angle, right? So this is the key factor. So the key feature of the right angle triangle, 90 degrees angle. So what it means? It means we just go and let's say vertical size also 1 centimeters. So we can go in a horizontal way and then lift up. So here's 2 units, basically just 1 centimeters. But let's first measure in units and cells. In here, 1, 2, 3, 4, 5. So here's 5. Okay, we've got Pythagoras theorem, right? Pythagoras. In order to find the absolute value for the length, we're actually going to apply Pythagoras theorem. So this is hypotenuse. So hypotenuse is actually square root of two other sides which are squared. So in cells, we'll get 5 squared plus 2 squared. V in cells means on paper right now, we've got square root of 25 and 4, so square root of 29. If you take calculator and have an approximate value for your, let's take square root of 29. Just want to see. Square root of 29. It's 5.38, let's say 51, okay? So that's why round up to the p, 2 decimal place, we'll get the value 5.39. Okay, that term in terms of cells. If you try to measure, probably 1, 2, 3, 4, 5 something, yeah, actually it works. We can actually check our workings. But right now, if I want to see what's the real size, so we said that 1 centimeters stays for the real size of the vector, right? And actually, let's say that every centimeters, because the speed and velocity is measured in meters, let's say per seconds, so we can say that every single 1 centimeters here denotes that it's, let's say, 10 meters per second. So how many centimeters first we have? Let's convert. So V in centimeters, if 2 cells for 1 centimeters, so we actually need to divide our value 5 square root of actually 29, if to be precise, we need to divide by 2, right? Because 2 cells in 1 centimeters. So we've got value 2.69. Okay, that's in centimeters. Now, if you have each centimeters to be 10 meters per second, finally we can get speed or velocity. So in this case, modulus of velocity, because we're measuring what? We're measuring the length, right? It's simply in meter per seconds, 10 times more. So we've got 26.9 now meter per seconds. So that's how you can convert or change what you have on your, let's say, what you have on your draft on the paper according to the scale. You can convert simply to real physical units. All right. So it has direction also, so we can measure the angle. But if you remember trigonometry, you simply can define the angle through trigonometric ratios. Let's try to do so. Trig ratios. Let's try to do this. So in this case, we have opposite side to adjacent 2 to 5. That will give us the tangent, right? Just remember connection. So that's your connection. In the triangle, you want to find the angle relative to horizon. Okay, let's say horizon. This horizontal line. So that's why tangent of this alpha is simply 2 to 5. And in order to find angle in degrees, you actually need to press 10 minus 1 on your calculator. Just if you're not sure how to do that, try to watch my trigonometry that covers pretty lot, so that you can be upgraded in this topic. Okay, so let's try to do so. 10 minus 1 of 2 over 5, or 0.4. So we've got alpha to be 21.8 degrees. Okay, that's how we can define direction. So I think this like example is really informative for you. That was the basics about vectors. And here is sort of like little task on the scale diagram. Sketch the vector which represent velocity of a 10 meter per second of the bike in a westerly direction. Okay, so we need to, first of all, we need to input the scale. So before we do that, let's say 1 centimeters is actually 10 meter per second. Okay, so centimeters here, and the green line is 2 cells. So actually, maybe it's better to say that, yeah, that's okay. We just zoom in. Okay, so we zoom in, and I want to set up 1 centimeters of velocity in a westerly direction. So first of all, we need to set up all the parts, all direction. So northern, eastern, southern, and west. Okay, we've got that westerly direction. So where? Towards the west. So that's our direction. Now, once we establish, we need to set up 1 centimeters. It's from here to here, and this is going to be our vector. So we found the length, and now we put a vector and saying that this is our velocity, which is 10 meter per second. Alright, so the next one, 30 meters per second on bearings 0.60. Wow, bike 30 meters per second, that's cool. So on the bearing 60 degrees, so we first put the northern direction, because your bearings is always measured from the north direction clockwise, so don't forget that. So clockwise direction. So hence we can set up the vector 30 degrees. Okay, how to figure out 30 meters? In this case, I'll just set up the ruler. Okay, let's set up here. And let's approximately, it's going to be about how many? 3 cells, right? Because we measured that 1 centimeters, that's our scale, is 10 meters per second. So that's why we also need to use a protractor, not only ruler, but also protractor that can measure, you know what? It can measure, oh, something wrong there. Okay, anyway. So we need to measure protractors. That is actually software bug. Okay, guys, from computer science, from ICT, you're welcome to put a patch on this software. Alright, so here is that protractor, and we need to use the angle of 60 degrees. So by my eye, I'll do that. And also I need to stick to the pattern 1 centimeters because the speed 30 meters per second. So actually 3 cells somehow, right? So 1 centimeters is 10 meters. So actually we need to put something like this. So this 1, this 2, and let's say this 3. So that's our vector, 30 meters per second with 60 degrees bearings. All right. So that's how it works. No problems. It seems to me that's the very basics. So make sure you understand that. Sorry for this software bug. Everything just lifted up for some reason. Okay, so anyway, I hope it's pretty clear for you guys. I'm not gonna waste your time. Don't forget to subscribe. That's my last words. Thank you for support. Thanks for newcomers, and actually waiting for your comments. What topics to create, because I know preparations for exams, it's hard. It's really like difficult task and problem. So guys, you direct me. Your comments are welcome. Peace.